This is a video looking at a recap of Year 9 chemistry for Year 10 chemistry. So before going into the different types of equations, how to write equations, different types of chemical reactions, it'd be good to first go over the basics of chemistry. So from Year 9 chemistry, you probably heard about matter. So matter is basically stuff. It's anything which has mass and takes up space. Takes up space or occupies a volume. Okay, it could be anything. It's lumps of stuff, whether it be a solid, liquid, or gas, or even plasma. Right, that's a form of matter. There are different forms of matter: solid, liquid, gas, plasma. And plasma is just a state sort of between liquid and gas. And solid, liquid, gas, plasma, they're typically made of atoms. Okay, the word atom comes from the Greek word atomos, meaning indivisible. But we now know that atoms aren't actually indivisible, they're divisible, which means they're made of smaller particles. So they're made of subatomic particles. Subatomic, sub means smaller than, atomic means atom related, so anything smaller than an atom, that's called a subatomic particle. I use the acronym PEN in my classes. So atoms are made of protons, P for proton, E for electron, N for neutron. Okay, three particles, very small particles. Protons are positively charged, P for positive. Electrons are negatively charged, and neutrons are neutral. They've got no charge at all. They're electrically neutral. I'll draw a simple atom. So this is I'm sure back in Year 9 you were familiar with these diagrams. Okay, this is called the Bohr atomic model. Okay, atoms are depicted as like a mini solar system, if you wish. So atoms have a very small and dense center where most of the mass, so 99.9% of the mass, is concentrated in the center of the atom. It's called the nucleus. It's like the sun. Okay, it's made of protons and neutrons, and it's got electrons which orbit around. Right, electrons are like the planets which orbit the sun. And this is an example of a helium atom. Okay, so helium is an element. So elements are basically pure substances. An element is a pure substance made of only one type of atom. And I say this to my students all the time. When you're buying a gold ring, let's say, you're hoping that it's made of gold atoms and nothing else, right? So that's what an element is. So other examples are hydrogen, carbon, oxygen, silver, copper. Okay, they're elements. Compounds are actually made of two or more different elements. Okay, for example, water. So a compound, I should write, substance made of two or more different elements. So for example, water, carbon dioxide, ... Okay. So water is made of hydrogen and oxygen, also written as H2O. Carbon dioxide, CO2, it's made of carbon and oxygen. So that's the basics of atoms and elements, compounds. Now let's go to the periodic table. So the periodic table is basically a chart of all the known elements in the universe. It's like a catalogue, if you wish. It consists of metals, non-metals, and metalloids, or semi-metals, in other words. Semi-metals. And most of the elements on the periodic table, they're metals. Right, they make up most of the periodic table. And the way the periodic table is written, it uses symbols and numbers just to make things simple. It's a convenient way of representing things. So an element is typically written like this. I'm just going to use different symbols. So A, let's call that X, let's call that Z. Okay, so for example, hydrogen is written like, or helium is written like this. Okay, on the periodic table. So A, that's the chemical symbol. Okay, chemical symbol. So the chemical symbol for helium, this is helium, is He. X is typically really depends on the periodic table, but X is the atomic mass. We'll talk about that in just a moment. Z is the atomic number. Okay, using this notation here. Okay. And atomic mass is usually the bigger number, okay? So in this case, it's 4. Helium has an atomic mass of 4 and atomic number of 2. So what's atomic mass? What's atomic number? Atomic number is simply the number of protons or electrons in an atom. Okay, and I've written or because the atoms that we experience typically in everyday life, they're neutral. Whenever you touch a table or a pen or a paper, it's typically neutral. You don't get zapped. The reason being is because it's electrically neutral and there's a balance of protons and electrons, a balance of positive and negative charges. Think of it like a seesaw. Atoms have equal amounts of protons and electrons. That's the atomic number. So in this case, helium has an atomic number of 2, so therefore it's got 2, as I drew here, 2 protons and 2 electrons. That's the atomic number. Atomic mass is the number of protons and neutrons. It's a total. The reason being that electrons isn't in the atomic mass because, technically speaking, electrons have mass, but their mass is so small that it's negligible, typically, right? Because most of the mass is concentrated in the atomic nucleus. Protons and neutrons have most of the mass, and so therefore that's the atomic mass, right, of the atom. So in this case, helium has got an atomic mass of 4. If you look up here, so it's got 4 protons and neutrons. Now to calculate the number of neutrons, what you do is you subtract, and I'll show you mathematically why this makes sense, atomic mass minus atomic number. Let me show you why. So atomic mass, I'm going to use just some symbols here. Atomic mass, let's call that P plus N. Number of protons, P, plus number of neutrons, N. Atomic number, let's call that P, right? Number of protons or electrons. Now from algebra, you know that P minus P is 0, right? So you're left with N plus N. And N is the number of neutrons. So that's how you work out the number of neutrons in an element. So for helium, it's 4, the atomic mass, minus 2, the atomic number, you get 2 neutrons. And so that's the basics of the periodic table. They're the basics of the periodic table, how to work out things like atomic mass, atomic number, and number of neutrons.